Hi everyone. Let's say we want to find the electric field created on the axis of a uniformly charged ring. So let's say that's the axis of the ring, and we want to find the electric field at the distance x on the axis. Okay, let's say at that distance. This is distance x. And the charge is distributed uniformly. Charge Q, let's say positive charge Q, is distributed uniformly along the ring. So let's take an infinitesimal charge. We're gonna call it dq. So this dq is going to create an electric field at this point. So the electric field at this point from dq is gonna look like that. That is dE. dE is the electric field created by dq. Now this dE can be resolved into x component and y component. If I consider this is the horizontal or x component here, and I can consider something like that to be the y component. But at the same time, if you took a dq directly opposite to the first dq, to the red one, this dq will also create a dE in this direction. Now you can see clearly that the y component of dE and the y component of the red dE are opposite to each other, so they will cancel each other. So we just look at the x component of dE. We just find the x component of dE. Alright, so let's find, and let's take this angle to be theta here. That's angle theta between dE and the x-axis. And let's continue this triangle here. So this angle theta is exactly the same as this angle theta. Now, dE, the formula of the electric field dE, it is K, Coulomb's constant, multiplied by dQ over the distance r squared. I'm gonna call this distance r, over r squared. Now if you look at this triangle, at that triangle here, this r squared is simply, by using Pythagorean theorem, it is x squared plus the radius of that ring plus r squared. So that's the k dq over x squared plus r squared. And now we need to find the x component of dE. So dEx is simply dE cosine of theta, and that's basically dEx. This is dEx. It is dE cosine theta, so it is k dq over x squared plus capital R squared. Cosine theta, if you also consider the triangle I have drawn, cosine theta is adjacent over hypotenuse. The adjacent is x and the hypotenuse is simply r. R, it is the square root of x squared plus r squared, or x squared plus r squared power half. So dEx is equal to k x dq over x squared plus r squared power 3 over 2. Power 3 over 2. Now, this dx, it's the x component of the electric field created by dq. So to find the total electric field, we simply integrate. So the total electric field is the integral of dx. It's the integral of dx. Then the electric field E is equal to the integral of k x dq over x squared plus r squared power 3 over 2. And this E is along the x-axis. You can write EX. So EX will be, we take the constants outside the integral. K is constant, X is constant, X squared plus R squared power 3 over 2, also constant. What remains in the integral is dq. Now what's the integral of dq? You are adding all of those infinitesimal charges. You are adding all of those small infinitesimal charges along the whole ring. So you will get the total charge. When you add all the dq's, you will get the total charge q. So instead of dq, integral of dq, I can write capital Q. And that's the magnitude of the electric field on the axis of a charged ring. Thank you for watching.